Hey everyone, and welcome back to AEL. Learn, create and build. Today, we will learn and simulate pull-up and pull-down switching using the Arduino Uno. So, what exactly are pull-up and pull-down resistors, and why do we need them? Well, imagine you have a switch connected to your Arduino. When the switch is pressed, it's easy for the Arduino to read high or 1. But what about when it's not pressed? Without a pull-up or pull-down resistor, the input pin can be floating, meaning it could read anything, high or low, due to electrical noise. It's like a boat without an anchor, just drifting. Pull-up and pull-down resistors give that pin a definitive state when the switch isn't active, making our reading stable and reliable. Alright, let's talk about what we'll need for this simulation. Arduino Uno. Push buttons. These will be our switches to demonstrate the pull-up and pull-down concepts. LEDs, one red and one yellow. These will light up to show us the state of our inputs. You can use any color you like. 220 ohm resistors. These are current limiting resistors for our LEDs to protect them from burning out. 10k ohm resistors. These are our crucial pull-up and pull-down resistors. The 10k value is a common choice for these applications. For the pull-down setup, we have our red LED connected to digital pin 9 through a 220 ohm resistor. Below that, our first push button, B2, has one leg connected to digital pin 6. The other leg of the button goes to 5 volts. Critically, we have a 10k ohm resistor, R3, connecting digital pin 6 to ground. This resistor pulls down the voltage on pin 6 to 0 when the button isn't pressed. When B2 is pressed, it connects pin 6 directly to 5 volts. For the pull-up setup, on the right our yellow LED is connected to digital pin 8 through its 220 ohm resistor. Our second push button, B1, has one leg connected to digital pin 5. The other leg of the button goes to ground. Here's the difference: a 10k ohm resistor connects digital pin 5 to 5 volts. This resistor pulls up the voltage on pin 5 to 5 volt when the button isn't pressed. When B1 is pressed, it connects pin 5 directly to ground. Alright, now for the brain of the operation, our Arduino code. You'll find the complete code in the description below, so feel free to copy and paste it into your Arduino IDE. Let's break it down quickly. First, we define our LED and button pins. In the setup function, we declare our LED pins as outputs and our button pins as inputs. Notice how for the pull-down button, we expect high when pressed, and for the pull-up button, we expect low when pressed. Take note of the initial state of the pin of our Arduino when the buttons are not pressed. For pull-down, its initial state is low or 0, and for pull-up, the initial state is high or 1. In our code, we set these initial states then use if-else to compare and give us an output. This is the key difference. In the loop, we constantly digitalRead the state of our buttons. If the pull-down button is high or 1, we turn on the red LED. If the pull-up button is low or 0, we turn off the yellow LED. Notice that we use 5 volts right? When reading a pin state, make sure the points at which you connect your input pin should not be greater than 5 volts. Else you blow up your Arduino. For the pull-down button, when you don't press it, the red LED should be off. When you press it, the red LED should light up. This is because the pull-down resistor holds the pin low until the button connects it to high. For the pull-up button, when you don't press it, the yellow LED should be on. When you press it, the yellow LED should turn off. Here, the pull-up resistor holds the pin high until the button connects it to low. And there you have it. We've successfully simulated pull-up and pull-down switching using the Arduino Uno. You've learned how these essential resistors ensure stable digital inputs, how to wire them up, and how to write the Arduino code to interpret their states. I hope you found this tutorial clear, helpful, and fun. If you enjoyed this video and learned something new, please give it a big thumbs up. Don't forget to subscribe to AEL and hit that bell icon so you don't miss out on our future uploads.